Okay, let's dig into this. If you fly modern automated aircraft, or heck, even if you just follow aviation stuff, you know the real moments, the ones that get your attention, aren't always the big, obvious failures. Sometimes it's these weird, transient moments where the machine just seems to stop talking to you. So today, we're doing a deep dive into one of the most, well, frankly, frustrating and maybe stomach-lurching bits of Airbus automation, this temporary abnormal behavior thing.
Yeah.
Specifically, the infamous MCDU freeze. The multifunction control display unit just locks up.
Yeah, that's exactly right. And our mission today, it's really laser focused. We are decoding that specific freeze, the one that happens right after you put in a complex flight plan change. Think DR2, hold, maybe adding an offset.
Hmm.
And we really need to tackle that message that pops up, the one that sounds, pretty terrifying. The white message, AC position invalid.
Yeah, I mean, to anyone, pilot or not, caught off guard, that message sounds like total disaster, right? But what's really interesting here, and what our sources highlight, is that this isn't framed as a genuine system failure. Not something that triggers the big ECAM warning and an emergency checklist. It's more like a software quirk, a transient thing.
That is the absolute core distinction. And honestly, it's the key to staying calm and in control. This specific issue, it's documented. It's in the ECAM, the Flight Crew Operating Manual, under temporary abnormal behaviors. It's basically an instance where the system gets momentarily, let's say, hum up. But, and this is crucial, the aircraft's actual navigation, it remains stable. Understanding that difference, well, that's what turns potential panic into just a procedural cleanup.
Okay, so let's nail down the basics first. When we talk about a temporary abnormal behavior, or TAB, how does Airbus logic actually define that? How is it different from a standard system failure? The kind that gives you flashing lights and checklists.
Well, the main definition really hinges on the lack of direct procedural guidance from the ECAM system itself. Standard failures, think engine issues, hydraulic problems, they're usually pretty clear-cut. They demand an immediate, very structured response. ECAM. TABs, though, they're different. They're these transient misbehaviors that don't trigger those formal ECAM checklists. They're often software quirks, things affecting the core auto flight functions, the FMGC, the flight management guidance computer, the FMS data processing. They're temporary hiccups, not permanent breaks.
Right, hiccups. And when do these hiccups tend to show up? Because they're not totally random, are they? It seems like they happen when the aircraft's brain is already working pretty hard.
Precisely. Yeah, you see them most often, especially in the A320 family,
Yeah.
when the system's under high computational load. So think complex flight plan changes, maybe putting in multiple DIR tows really quickly, or setting up a holding pattern, especially if you do this during flight phases where the geometry is already changing fast, like maybe a non-standard climb or during an approach.
Okay, let's walk through that classic scenario then, the one that leads right to this freeze. What might the crew be doing?
Okay, so the crew goes to the lateral revision page, the LET-RV page, right? They want to input a change, maybe set up an offset for weather avoidance. They punch it in, confirm it, and they're expecting the route on the screen to update instantly. But instead, bam, the MCDU just freezes solid, display locked, keypad dead. And then that slightly alarming text appears in the scratch pad. AC position invalid.
Okay, that message. This feels like the absolute heart of the matter for this deep dive, because the color of that text changes everything, doesn't it? It's the difference between a real emergency and, well, a software annoyance.
Absolutely. This is the piece of knowledge you just have to have filed away. If that message, AC position invalid, shows up in white, that's your signal, your immediate, maybe counterintuitive confirmation. It means only the MCDU interface itself is frozen. That's it. The critical point here is the aircraft's actual navigation solution is still valid. It's still good inside the FMGC. The plane still knows exactly where it is and where it was going based on the last valid plan.
Wow. Okay, that is definitely counterintuitive and hugely reassuring, but only if you know the code, so to speak. So white text means temporary communication breakdown with the interface, but if that same text were, say, amber or yellow, that's a whole different story, right?
Oh, completely different ballgame. Yes.
Oh.
If that message showed up in amber, that indicates a genuine problem, a real loss of navigational position integrity. That would likely signal a major sensor failure or maybe a big disagreement between systems, and you'd be looking at a totally different procedure, almost certainly ECAM-driven, probably involving cross-checking your inertial references, the raw data. But the white message, that confirms the problem. It's just a computational traffic jam, basically, not a loss of navigation.
Okay, that leads us straight to the why. If the navigation's okay, why can't I talk to it? Why can't I input anything? What's actually causing this interface lock?
So the root cause, fundamentally, is that the flight management guidance computer, the FMGC,
Uh,
the brain, essentially, it's entered this temporary data processing
yeah.
deadlock, a kind of internal loop. You gave it a new complex geometry problem to solve, like calculating that holding pattern entry or figuring out a curved offset path. And it's now dedicating pretty much all its processing power to solving that specific problem.
Okay. So it's like its internal processing gets so focused on crunching the numbers for that new path that it actually forgets its other job, which is updating the screen and listening to the keypad.
That's a pretty good way to put it, yeah. The system is stuck iterating, recalculating the active flight leg geometry based on your new command.
Yeah.
And while it's cycling through that complex calculation, the FMGC effectively blocks the refresh signal to the MCDU interface. The inputs are physically disabled because the computer literally can't accept new data while it's still trying to resolve the current calculation.
Which means the lockup is temporary. It's a side effect of the FMGC working really hard on complex math. It's not a deep hardware failure, and crucially, it's not a loss of navigation. That's the big takeaway for everyone listening. The plane's fine, the interface is just taking a break.
Exactly. Think of it like an internal software argument that's blocking external communication.
Yeah.
But the output, the commands go into the autopilot, the flight director, that's all still based on the last known valid flight path information.
Okay, understanding is great, but action is what counts in the cockpit. So what's the immediate crew action? We recognize the white message, we confirm the freeze, we're past troubleshooting, we need the specific fix, the procedure.
Absolutely no troubleshooting here. It's a straight system reset procedure. Once you see that white message, confirm the keypad's dead, you immediately go to the procedure in the QRH, the Quick Reference Handbook.
And where exactly is that procedure tucked away in the QRH?
You'll find it under the A320 FLT section. The title is something like AU2 FLT, both MCDU locked or blank or FMGC malfunction. And the goal is pretty straightforward. You need to successively reset both FMGCs, but critically, one at a time. This forces them out of that processing deadlock and gets the normal data flowing again.
Right, let's break down those resets, because this is where it gets super important to follow the procedure exactly. And mixing these two up could cause real problems, yeah.
Oh, absolutely vital to get this right. So first, you've got the short FMGC reset. This involves pulling the specific FMGC circuit breaker, waiting about 10 seconds, and then resetting it. Just a quick cycle. Its purpose is simply a quick reinitialization of the data processing, get it unstuck. And crucially, it preserves the existing flight plan. All your INIT data, your route, it stays loaded. This is the quick one, and it's the one you use in flight, specifically for recovering from a tab like this MCDU freeze.
Okay, short reset, 10 seconds, keeps the flight plan used in flight. Now, the other one, the bigger one, the long FMGC reset.
Yes, the long reset, and the name hints at the difference. It lasts way longer, up to 15 minutes. This involves a much deeper reboot, a reinitialization of a whole computer architecture. But the trade-off is huge.
Yeah.
It clears everything, all stored data, your entire flight plan, INIT pages, PRF pages, wiped clean, gone. Because of that, this procedure is used only on the ground, usually with maintenance involved.
Cannot stress that enough, right? Never, ever perform a long reset while airborne. If you pull that breaker for 15 minutes in the air, you essentially lose your primary navigation guidance. You're back to basic flying instantly.
Precisely. Imagine trying to manage a busy arrival or departure, and suddenly your entire flight plan database vanishes. You'd have to manually re-enter everything: route, performance, weights, while trying to fly the aircraft on raw data. That kind of data loss airborne is completely unacceptable, extremely high workload. If you accidentally start the long reset timer airborne, the only recovery is reverting to basic radio nav, VORDME, while that computer takes forever to reboot.
So short in the air preserves data, long only on the ground wipes everything. Got it. And there's one final rule about doing both at once, something about the circuit breakers.
Yes, that's important too. The FMGC circuit breakers are typically on the overhead panel, and the rule is very strict. A dual simultaneous reset, pulling both FMGC breakers at the exact same time, is only ever attempted on the ground, and only with the engine stopped. If you're airborne and need to reset both, you do it sequentially, one at a time. Reset FMGC 1, let it come back online, confirm it's working, then reset FMGC 2. This ensures the remaining FMGC maintains continuous position awareness and flight guidance, while the other one is briefly offline during its short reboot.
Okay, that makes sense. Which brings us nicely to sort of operational mastery, the good practices, things you can do to maybe prevent these freezes or at least manage them smoothly if they do happen. How can we be proactive?
Yeah, prevention really starts with just being mindful of the workload you're putting on the FMGC. It's powerful, sure, but it's not infinite. So avoid performing really complex modifications like DIRTOs or setting up whole Ds in super rapid succession. Give it a beat. Let the FMGC digest one big change before you throw the next complex geometry puzzle at it. Especially be careful near a waypoint sequence point where it's already busy calculating the turn onto the next leg.
Right, slow down the inputs a bit.
Hmm.
And what if you feel the MCDU getting sluggish before it actually locks up solid? Is there anything you can do then?
Yes, definitely. If you notice the MCDU response is getting slow or maybe the scratch pad seems laggy, immediately, just momentarily, select HEGDUT mode on the glare shield. By selecting heading or track mode, you tell the autopilot to just follow a simple direction instead of the complex FMS flight path. This instantly reduces the FMGC's immediate navigation calculation burden. It gives it breathing room to catch up on its internal sums, and often that can be enough to prevent the deadlock from happening in the first place.
That's a great tip, a really practical mitigation strategy. Okay, and finally, if the freeze does happen, maybe during a busy phase, let's just reiterate those two critical facts that help prevent panic.
Okay, number one. Remember, the aircraft system design is robust against this. It continues flying the last valid trajectory it had. It won't just fall out of the sky or turn randomly. And number two, the automation will not just disengage because the MCDU screen is frozen. Your autopilot, your auto thrust, they are still engaged, still working based on the last valid commands they received. So your attention needs to shift immediately to the navigation display and the flight mode annunciator, FMA, to confirm what the aircraft is actually doing, not staring at the frozen MCDU.
Right. Focus on what matters, the actual flight path and automation modes. And what's the required follow-up action for the pilot once things are back to normal?
Two things. First, always confirm the active leg on your navigation display and check the FMA modes after any lateral modification, reset or not. Just good practice. And second, absolutely critical. You must log the event immediately in the aircraft's technical log. Maintenance and engineering need that data point, the date, time, phase of flight, what you were doing. It helps them track these transient behaviors, correlate them possibly with specific software versions, and feed that info back for future system improvements.
Okay, so we've really unpacked it. The frozen MCDU, especially after those complex inputs like DIR, TO, or hold, it's a known temporary abnormal behavior. And that single crucial piece of knowledge, the difference between the white AC position invalid message and an amber one, that's the absolute key to managing it calmly and professionally.
That really is the gist of it. Powerful automation like the FMGC isn't immune to these occasional hiccups or temporary deadlocks, especially under heavy calculation load. But knowing the specific reset procedure, the short reset, one breaker at a time in flight and understand the system's behavior, transforms what could be a moment of automation, surprise, or even fear into just a demonstration of procedural knowledge, system understanding, and calm cockpit management. It's about mastery, not mystery.
And that actually leads us to a final thought, something for you, our listeners, to maybe mull over. Consider this. The aircraft keeps flying correctly, following its last valid path, even when its primary pilot interface, the MCDU, is frozen and effectively telling you it doesn't know where it is. This inherent redundancy, this ability to keep going despite the interface glitch, raises a really interesting design question, doesn't it? How critical is it, really, for certain core navigational data, maybe position, track, altitude, to always be visible and accessible to the pilot, completely independent of the main FMS interface? Something to think about regarding standby instruments, raw data backups, and system architecture as you digest all this.